Hi everyone. We are going to learn how to multiply radicals today, which actually we've already been doing a little bit of. So we already know this property that we can split a radical as two separate radicals with multiplication in between. Okay. And a couple helpful hints when multiplying radicals is to simplify any radicals before you even start if you can. So for example, 18 can be split into 9 and 2. This can be split into 3 and 3. We can make our group right there, and we can box our leftovers. So remember that the groups go on the outside, the boxes we take home. So 3 root 2 times 2 root 6. So that's step 1. Then we multiply the coefficients together and then multiply the inside of the radicals together. So another way to think of this is multiply outside times outside. And then multiply inside times inside. So when we do that, we get 6 root 12. And then it's really important that we pay attention to the last step, which is to simplify your final radical if possible. So if you got this far, you would definitely receive credit, but you wouldn't receive full credit because 12 can get broken down into 4 and 3, 2 and 2. So I can make a group of 2's, and I can box my leftovers. Okay. And then make sure that we multiply the number in front, so 6 times 2 root 3. So my final answer is 12 root 3. Sorry, if you heard that, that was wriggly. Okay, so let's take a look at example 1. Okay, first of all, see if you can simplify either radical. Well, 7 breaks down to 7 1, 14 breaks down into 7 and 2, so we can't combine anything. So let's go ahead and multiply these two radicals together. Multiply the outsides together, but the outsides are only 1, so this is just going to be root 98. And then at the end, we have to see if we can simplify this, which we can. This is 49 and 2, 7 and 7. I can take a group of 7's out, and I can box my leftovers. So this equals 7 root 2. Let's go to the second example. Remember to look before you cross the street. See if you can simplify them first. And this problem is actually really nice because the cube root of 8 is just 2. And we just get 4. Okay. In example 3, once again, look before you cross the street. So we do have some simplifying we need to do first. This can get broken into 9 and 2. This is 3 and 3. So I have 1 leftover. And I have 1 group. Make sure to multiply by the number in front. Okay, so from here, and sorry if you hear Rocky and Wrigley in the background. From here we have 3 times 3 root 2 times root 6 times, I'm going to put this in parentheses so we make sure that we don't accidentally subtract those. So we multiply everything in front. So we've got the 3 times 3 times negative 2. That goes on the outside. So that's going to be negative 18. And then the square root of, multiply everything on the inside. So 2 times 6 times 2. And that's going to be 24. Okay. And then we have to look to see if we can simplify any further, which we can because this is 6 and 4, 2 and 2. So I can make a group of 2's. Yes, I know I can split the 6, but it's not going to make a group, so I don't need to worry about that. So negative 18 times 2 times the square root of 6. So my final answer is negative 36 root 6. Okay. All right. next example. Remember that when you square something, that means it's times itself. That the only thing that's being squared in this example is the root 5. So this is negative 3 root 5 times root 5. That's negative 3 root 25. Hopefully you recognize that 25 is a perfect square, and my final answer is negative 15. Okay. The whole point of you guys watching the video by yourself is so that you can pause and write down anything extra that you need to. Okay, so once again, look before you cross the street on this problem. Notice that we are cubing a cubed root, okay? So everything on the inside has to go to the power on the outside. So we have to take 2 to the third, you have to take the cube root to the third, and that's actually just going to cancel itself out. Because we have 2 to the third times the cubed root of 72 to the third. Remember that when the power and the index are the same, they just cancel each other out. So 8 times 72, and we get 576. Okay, so look for those little shortcuts as you're doing these problems, because it's going to save you some time and possibly even some confusion. Okay. So this one, yes, I know we said to simplify your radicals first, which you can do. But if you look at it, when you distribute this one here, that's going to make a perfect square. So I'm actually going to leave them the way they are because it's going to create less work for myself in the end. So 3 root 2 minus root 36. So we get 3 root 2 minus 6. And that's it. Okay. Make sure that the 2, you don't multiply it to the 3. Okay, the 2's underneath the radical, so it stays inside. The 3 goes on the outside. Then here, underneath, so you multiply the 2 together. Okay, let's look at number 7. So for number 7, we can't simplify anything first, so we're going to go ahead and multiply these 2 radicals together. So we get 20 x squared y, and then simplify if you can. So 20 can get broken down into 4 and 5, 2 and 2. So I can box a 5. I can take a group of 2's out. Okay. So I have, I have 2 root 5, x to the 2 over 2, y to the 1/2. Okay, technically you don't even need to write y to the 1/2. You could just keep it under the radical because remember if the power is not bigger than the index, you can't simplify anything. So this is going to be 2x, and then the square root of 5y. All right, let's go ahead and look at number 8. Some of you might notice that you could actually simplify those w's before you even started the problem, but it's not going to help us too much, so I'm going to go ahead and just multiply the 2 together. So we have the 4th root of 80, w to the 6th, z to the 3rd. So since we are working with the 4th root, I need to look for a group of 4. So this is going to be 16 and 5, 4 and 4, 2 and 2, 2 and 2. So I have a leftover of 5, and I have a group of 2's. So I have 2, 4th root of 5 times w to the 6 over 4, z to the 3 over 4. Okay. And I'm not going to reduce that fraction because I need to keep the index, which is the root, the same. So I can take out a w, and we're left with 5w squared z to the 3rd. Okay. Once again, technically I didn't need to do this part because if the power is not bigger than the index, It's just going to stay under the radical. It can't go anywhere. Okay. All right, last example. Go ahead and distribute. Make sure you multiply outside times outside, inside times inside. So 21 root 25, and then 6 root 5. See if anything can simplify. Root 25 can. So you get 105 plus 6 root 5. Okay. You guys have the rest of the time to work on your homework, help each other out if you guys have any questions, and I will see you the next day. Bye-bye.